Dear students, in this section we are going to learn how to analyze the acceleration of the lowest point of a body rolling on a fixed curved surface. We will learn this application through one selected illustration. So let us move to illustration part. In this illustration we are given a cylinder of radius small r. It is rolling perfectly with a constant speed v on a concave surface of radius capital R. Here we need to find the acceleration of point P of the rolling body. P is the lowest point of this rolling body in contact with the track. We need to find the net acceleration of this point P. Let us make the diagram to the next page. This is the situation. Okay. This is a fixed track. That means it is not moving. And our body, our cylinder is rolling over the curved surface. And our point P is in contact with the curved track. That means the velocity of the point P should be 0 because it is the case of the pure rolling. For making net velocity of point P 0, the rotation sense of this cylinder should be in the clockwise sense. Let us assume the angular velocity of the cylinder is omega. This is the angular velocity. Okay. Now let us write the vector equation of acceleration of point P. Acceleration of the point P should be equal to acceleration of point P with respect to C plus acceleration of C. First of all, we will consider acceleration of point C, which is the center of the cylinder. Okay, we know the center of the cylinder is rotating about O. The radius of rotation of this center is equal to capital R minus small r. Okay, so we can say the acceleration of point C should be equal to the radial acceleration of C because it is on the circular track. It is moving on the circular track. It means the acceleration direction of point C should be toward O like this. It should be in the upward direction. Okay, that is toward O. Now let us assign our coordinate axes. These are our coordinate axes. Right side direction we have considered as positive x direction and upward direction as positive y direction, and direction perpendicular to the screen and toward you is our positive z direction. Now we can write the vector equation of this acceleration, that is the acceleration of C. You know, radial acceleration magnitude is equal to velocity square divided by radius, and velocity at this position is v and radius of rotation is capital R minus small r, and direction is toward positive y direction. That is unit vector should be involved, that is j cap. So let us write the equation for the acceleration of C, that is v square divided by capital R minus small r j cap. Okay, this is the acceleration of point C, that is the center of the cylinder. Now let us consider acceleration of point P with respect to C, this acceleration. For this purpose, you should consider you are observing from C moving with the cylinder. You will find the motion of the cylinder as pure circular motion. If it is pure circular motion, that means the point P is rotating about C. C is the location of the observer. It means point P should have the two components of the acceleration. One is the radial acceleration toward the center, other is the tangential acceleration. This is the radial acceleration and this is our tangential acceleration. Okay, and we know our cylinder is moving or rotating with a constant angular velocity and moving with a constant linear velocity. That means the tangential acceleration of the cylinder should be 0 and radial acceleration should be equal to omega square multiplied by radius of the rotation, that is equal to small r. So let us write the radial acceleration of this point P with respect to C, that is omega square small r j cap. J cap is in upward direction and this acceleration component should be equal to 0. So this tangential acceleration, that is acceleration of P with respect to C in the tangential direction, that is equal to 0. Now let us substitute the value of acceleration of P with respect to C and acceleration of the C in this equation, and we know acceleration of P with respect to C is equal to omega square r j cap and acceleration of C is equal to v squared divided by capital R minus small r j cap. So let us substitute these values. This is the acceleration of P with respect to C and this is the acceleration of C. Okay. And we know if cylinder is rolling, we can write omega is equal to V divided by small r. Now we can substitute the value of omega in this equation, right? So we can write omega square r equal to V square divided by r square multiplied by small r. That is equal to V square divided by small r. Now we can substitute the value of omega square r in this equation. So we will get the acceleration of point P, which is the lowest point, as V square divided by small r plus V square divided by capital R minus small r multiplied by j cap. J cap is the unit vector. You can say the acceleration of the lowest point should be directed in the upward direction, having the magnitude equal to V square by small r plus V square divided by capital R minus small r. Okay. Dear aspirants, Cengage India has launched the new edition of our JEE Advanced Physics books. Please visit www.cengage.co.in to buy a copy. You can also buy the books from Amazon or Flipkart.